So welcome everyone. I welcome you all to today's free session on acing geometry. First things first, let me introduce myself. My name is Harsha. I'm one of the experts, one of the subject matter experts at e-GMAT. For those of you who are familiar with the e-GMAT universe, you guys typically see me in verbal, but today I'm going to be your primary host for this particular session on geometry. I also have a co-host with me. Anshuman is a quant specialist and he's here to help us out with any doubts or queries that you might have. So over the course of the session, if something is not clear, if you put a doubt in the Q&A pod or even in the chat pod for that matter, Anshuman is here to help us with those queries as well to ensure that your doubts are addressed. So very happy to see around 40 of you here and more of you joining throughout, as the seconds progress. First things first, let's talk a little bit about today's session. Today's session is about geometry, but very specifically one aspect of geometry, that is quadrilaterals. So it's a very interesting session. This is a session that I like to call a skill building session. So it's not a workshop where you're going to solve 15, 20 questions, with time constraints. No, this is not that kind of session. This is what we call a skill building session. We start from scratch. We take you to that level necessary to solve those difficult questions. So in order to help you out, prepare for the session, in order to help you prepare for the session a little bit, we had sent a couple of video lessons your way. These are the activities that you see here. If you have gone through this, great, that's going to set you up for today's session. But even if you have not had the time to go through it, absolutely no problem. This session will help you. And if you like what you see here, if you find the approach that we follow to be useful, do consider signing up for the free trial and checking out these concepts. These are part of your free trial. All right. Let me also quickly tell you about our upcoming sessions, because we keep doing these sessions again and again to ensure that a lot of students are reached through these activities. So next Saturday we have our GMAT strategy webinar, and when I say GMAT strategy, it's all about how do you prepare in terms of making a study plan, in terms of executing on all those processes you need to ensure that you're able to get your GMAT score. It's not about the subject matter per se, but it's about how you get there. So if you are somebody who needs to kind of figure out how does a 740 or a 760 plus GMAT scorer actually prepare for GMAT, this session is for you. It's going to give you all the context that you need. So this session is on Saturday. If this feels like something up your alley, feel free to register for this particular session. And on the coming Sunday, we also have one of our favorite sessions. It's at least one of my favorite sessions. It's called Number Properties. It's the GMAT Number Properties webinar. So this is another skill building session where we take number properties and we kind of provide you with a unified approach. It's a unified, structured approach that works irrespective of the level of difficulty. The easiest questions and the toughest questions in number properties, this is an approach that will help you irrespective of what kind of question you're dealing with. So if you need a little bit of support with number properties, this session can help you out. Do consider registering for that as well. With that, before we get into the core session, let's understand the composition of today's batch. I see around 50 of you here. So the first question, feel free to fill this poll and let me know, when are you guys planning to take the GMAT? Another question that I'm typically interested in finding out is, as far as quant goes, what is your current level? For those of you who have taken mocks or have taken the exam before, you might already have a good idea of where you stand right now. So if that's the case, feel free to document that here as well. All right, so if I'm looking at the first piece of data, when are you planning to take the GMAT? At least around half the batch has not yet decided yet, which means you guys have time. So once the session is done, and if you want to attend the number property session next week, attend that also and get an idea about what does it take. The strategy session on Saturday is going to be very useful for you guys. It will help you plan your studies. Okay, what kind of date should I pick? How long should you take to prepare? Those are the kind of questions that you should get answered through the strategy session. This session will be useful for you because you'll see a fresh approach to geometry. As far as those of you who are taking this test in the next 15 days or the next 1 month, you should still see a lot of benefit from what you see in this session today, because there are no hacks, there are no shortcuts that we teach. It's all about proper process of doing any question, right? No hacks, no shortcuts, but very logical principles at work. So let's look at the second question. In your own view, what is your current quant ability? So this is good. 32% are in that Q30 to Q47. Then some of you are in that, another 5 of you are in that Q48, Q49. Nobody here is already at that Q50, Q51. Usually I see one or two, so I'm surprised to see that. So hopefully this session will help all of you move forward in this particular journey. All right, this is good. Thanks a lot for sharing that details. Now let's get into the core presentation pane. And let me just move this. So as this fills in, you should see the presentation load. I'm not sure it's visible yet. If the presentation is visible to you, if you can see skill building session geometry 2.0, you can use the chat pod to let me know that you can see it. So we're going to have an interactive session. We'll try to interact as much as we can. And so you have the chat pod. This is for us to converse. I can ask you a question. You can put in the answer there if it's not a poll question. And you also have the Q&A pod that's at the bottom. If you put a question there, either I or Anshuman will be able to address it through the course of the session, right? If it is on the chat pod, because a lot of us are having those conversations, questions can get lost. So if you want a question answered, I always suggest put it in the Q&A. That way we can see it, right? It doesn't get lost. All right. So I don't know about the Monday session, but all the sessions right now are the free sessions. We're not doing paid sessions at this point. So definitely it's free. All right. So very quick show of hands. You guys can see the skill building session. And just give me 1 second as I bring in my annotation. The reason for that is I do scribble a lot. So, all right. So let's get into today's session. Okay. What are we going to do today? Let's start with that. So this session is very interestingly designed. Though it is a skill building session, but we're not gonna start at the absolute zero. First, you're going to get a flavor of the toughest questions that we have for you today. You're gonna solve 4 700+ questions right at the outset. The purpose behind doing this is to get an estimate of your current ability. You'll see how well you're able to solve these questions. Once you solve these questions, we're gonna run through a little bit of conceptual. So when you talk about quadrilaterals, there are some properties of quadrilaterals that you should know. So we're going to test you on whether you know those basics well, the basic concepts of quadrilaterals well, and based on how you perform, we can give you feedback on that as well. It will tell you where you stand currently as far as the conceptual abilities are concerned. Okay. Once that is done, we're going to get into the crux of learning and building ability. So we're going to introduce something called as process skills. I'm going to do some exercises that are designed to help you improve on these specific skills. Okay. My internet is showing well. Can you guys hear me? Just put yes if you can hear me. No if you cannot hear me. That way. Yep. Thanks a lot for that confirmation. At this point, my internet is doing fine. But yes, if it does fluctuate, I will also know, and you guys you can also let me know. I'll be happy to redo any point that I missed. All right. So then we're gonna get into something called process skills and try to improve our abilities to solve these questions. After that, I'm going to take a quick 10-minute, 15-minute breather to explain how all this architecture came up and how currently e-GMAT helps improve students in terms of quant ability. After that, we're going to get back to practice using these process skills. We're going to continue those exercises, and over the course of all this, you're also going to see that we will be coming back to these questions. And by the second round, by the time you're coming to these questions again, typically what I expect to see is an improvement. If let's say 30% of the class got the answer the last time, usually I would see say 40%, 50%, 60% or 70% get the answer the second time. We'll see if that happens with this batch. So I have great expectations from you guys. I hope we deliver. All right. So I hope the agenda of what we're going to do today is pretty clear. Now, the simple rules of the room. Any question that I bring in, I'm going to introduce a poll. So for those of you who have attended e-GMAT sessions before, you kind of already know this exact aspect. So how we're going to do this is very simple. I don't want to time you guys. Typically in a timed environment, yes, I would time you guys, but here I actually do not want to put any time constraint on you. So that's why we have this option called still solving at the bottom. So just give me 1 sec. Let me minimize this a little bit. All right. So you see this option called still solving that's at the bottom. That's my way of timing you guys today. When I see that a lot of us have solved the question, that means from still solving you would have gone to A or B or C or D or E, whatever, then I know that I should move on and I should come to the next question. So all of you who are here, around 75, 80 of you are here, why don't you click on still solving so that I can introduce the first question. All right. I liked seeing that spike. So let's get right to it. Here's your first question. The questions that you're going to solve right now are all data sufficiency questions. So let's have a little bit of fun with this. Geometry is meant to be a lot of fun. Okay. So here you go. All the best. Here's question number 1. All right, so let's start getting your answers in. I see that more and more of you are finishing it. I'll give you a little more time for this. Given this is your first question, you may need a bit of warm. All right, so most of you are done. I'm going to give you another 15 seconds and then you're going to start with the next question. 3, 2, 1. And before I end the poll, anybody wants to take your best guess, take your best shot. And 1. So I'm going to end the poll and let's move to the second question. Okay. Before I do that, any of you wants to note down the answers that you have chosen, just in case you don't want to miss out on it later? I'm going to broadcast the results. Make sure you take a note of the answers, okay? Anyway, now let's move to the next question. Same principle as always, folks. Start by clicking on Still Solving. That sets the initial estimate. So while you do that, quick context on the second question that you're going to solve. It's a variation of the same question. So we have kind of changed the parameters that are mentioned. So pay attention. It's almost the same question, but be careful. All right. So here's question 2 for you. All the best. Or rather, this is called question 1A, as it's a variation. All right, around 75% of the batch is done. I'm going to give another 10-15 seconds for you. All right, so last 5 seconds. 3, 2, 1, and take your best shot for anybody who's still trying. And 1. So I'm going to end this poll. We are going to go to the next one at this point. So I hope you folks are having fun. These are all interesting questions. So let me broadcast results if you guys want a quick peek at how everybody polled. So now let's go to question number 3. So the approach remains the same. I'm going to just bring in the poll. All right, folks, still solving for a quick estimate of who's done, who's not done. Because that's my green signal to introduce the question to you as well. All right. I don't know how some of you have already chosen option C and D for this next question, which I've not yet introduced. I hope you guys are not confused about which question we're dealing with. But anyway, here's the question. All the best. Most of you are done. Let's try to wrap this up in another 15 odd seconds. We have one more interesting question to go. All right, everybody. So let's do a 10-second count. Last 10 seconds. 3, 2, 1, and take your best shot before I close the poll. And 1. So I'm going to end the poll right now. And let me quickly broadcast the results if you want to take a quick peek. Okay. So now let's come to the last set in this last question in this particular set. After this, we are going to start our discussion. All right. So as always, folks, start by clicking on still solving. Right. So here's the question number 3, your fourth question of the day. All the best. This one does seem to be taking a little bit of time. I'm going to grant you that time. All right, folks, let's take a last 15 seconds and then begin discussing. Five, 4, 3, 2, 1. And anybody wants to take a shot? Some of you in that still solving bucket, take a quick guess. Trust your guts. All right, so I'm gonna end the poll right now. That's great. So here's the thing. We're gonna come back to these questions later. So we're not gonna discuss these questions right now. We're gonna build our ability and then come back to these very same questions later. So let's hear from you folks. How were these questions? How easy or difficult was it for you? Any observations? Got rocked. By the end of the session, it will be a lot clearer how to do. But these are difficult questions. So there's a reason these are all 700 plus questions. And given that it's data sufficiency, yeah, it can be a little tricky. So Ritvik says, I have a hang of geometry, so it was not very difficult. Very, very good. I'm happy to see that. Medium difficulty, good questions. Very tricky. All right. So a lot of us did find these questions at least somewhat tricky. I can also say that based on the results I saw. In most of the questions, a lot of us did not get anywhere near the right answer. I can see that. So once we discuss it, you're going to see that as well. All right. So now you solved 4 700 plus level questions. But now let's get into concept. So what we're going to do now is I'm again going to give you a quiz, but this time it's concept specific quizzes. When I say concepts, this is not number properties. If it was number properties, you should know about the divisibility rules. Those are concepts. When it comes to geometry and very specifically quadrilaterals, what do I mean by concepts? You should know the properties of all these quadrilaterals that the GMAT tests you on, right? You should know how to find the area of a trapezium, for example. So we're going to give you 2 sets of concept related questions. So each set is a set of around 8 statements, and you need to say which of these statements is true. Okay, clear so far? Again, I'm going to give a poll for this, and let me bring in that poll as well. So the idea here is, if you're really very strong conceptually, you should be getting most of these questions right. These are all the basics of quadrilaterals, testing you on your knowledge of quadrilateral properties. So let's bring those questions here. Here the task is very simple, okay? Only mark those statements which as per you are true. So let's do this. Here's the first set. You have, by the way, this is multiple choice. If you find that option, if you find that statement 1 as per you is true, click on that one in that poll. That's the approach. Likewise with any of these statements. This should not take time. I don't expect you to work all this out at this point. These are things you should know if your concepts are very, very strong in quadrilateral. So adjacent means side by side. Yeah, Ritvik answered it correctly. It's the one that is next to whatever you're looking at, okay? I'm giving you a little more time, but I still see a lot of you still doing this. All right, so last 10 seconds. I think that should cut it, right? Let's get into it. Congruent means absolutely same to same. For example, if two triangles are congruent, all their sides are equal, all those angles are equal. If ABC and PQR are congruent, that means all the sides of ABC are the same as all the sides of PQR, all the angles of ABC are the same as are the angles of PQR. Same to same. Everything is same. That's congruent. Yeah. Alright, so last 5 seconds and then let's go to the next set. 3, 2, 1. Alright, so the objective of these questions, by the way, is not for all of you to work out each and every quest statement here. These are things that are more like factoids. You should kind of know if your clarity, conceptual clarity is very strong. So I'm going to broadcast the results for a quick peek. And now another similar set of questions for you. But by the end of these two sets of questions, it will give us an idea about where we stand. All right, so let me bring the second set in. The approach is the same, folks. It's just a set of 8 questions. So all the best. Again, your task is the same. Select everything which you believe is true. I see a lot more speed with this set. So a lot of you are almost done. I'm going to give you another 15 seconds and that's it. Bisect means it divides it by 2. So if you have a a line segment of 10 centimeter, bisecting means 5 centimeter, 5 centimeter. I used centimeter because you have that as your name, CM. All right. All right, so last 5 seconds, folks. 3, 2, 1, and let me pause. All right. So when you were answering these conceptual questions, how many of you really got stuck? Like, okay, I'm not sure about this. And how many of you were able to run through this list with confidence? Because some of these are not easy. Some of you are able to run through. Exactly. So there it will tell you exactly how deep your knowledge of quadrilaterals is. And because quadrilaterals, the concepts, you should know the properties of each and every type of quadrilateral. It's as simple as that, right? If you have a death grip on this, you would be able to do this. Confident in the second list. All right. Very, very good answers. Very happy to see that. But everybody, we're all going to learn some things now. So do pay a little bit of attention to this next set. So I'm going to quickly run through the answers here. Now, my objective is not to explain these in detail. Okay. Don't worry about that. Don't worry about diagonals. I'm going to give you some basis for that as well. My expectation here is not to run through these things, is not to explain all of this in detail, because I will be sharing the PDF with you and there's this very specific slide that we are going to go through very specifically. And once you spend time on that, when you come back to these statements, you will be able to figure out all of this on your own. Okay. So the first set was harder, absolutely. So now let's kind of discuss this. And again, just focus on everything that we're discussing. So the first statement says all 4 triangles formed by the 2 diagonals of a parallelogram are congruent. I already explained what congruent is. They're exactly same to same. In reality, no. Even the diagonals of a parallelogram, they are not equal. And when your diagonals itself are not equal, those 4 triangles definitely are not congruent, which makes it incorrect. The adjacent angles are equal in all parallelograms. Actually, the adjacent angles sum up to 180 degrees. They're complementary. If you take your typical parallelogram, if this angle is 60, this angle is also 60. The adjacent angle is this one. It is actually 120. So you cannot say adjacent angles are equal. Actually, the adjacent angles are complementary. They sum up to 180 degrees, which makes this one, yeah, supplementary. I could be wrong. Complementary, I believe, is 90, so supplementary. Thanks for the correction. Absolutely. So they sum up to 180 degrees. Let's avoid the jargon entirely. So adjacent angles are equal? Absolutely not. Adjacent sides are equal? No. Adjacent sides are equal, that means that would make it a rhombus, right? All 4 sides being equal. Adjacent sides are equal. Opposite sides are equal in a parallelogram, not adjacent sides. So this is also wrong. All diagonals are equal in a parallelogram? Absolutely not. All the diagonals are equal in squares and rectangles, not in parallelograms and rhombuses. Don't worry if this feels like, okay, how do you know? These are things that you eventually know once you go through the course, once you go through some theoretical aspects of the quadrilaterals. Sum of opposite angles in a parallelogram. Okay, I'll answer that question. So what makes a parallelogram a rhombus? Imagine a parallelogram where all the sides are equal. In a typical parallelogram, opposite sides are equal, but not the adjacent sides. If all the sides are equal, that makes it a rhombus. Okay, we're going to discuss this, so don't worry about that. So let's look at statement 5. The sum of the opposite angles is 180 degrees. No. Sum of the adjacent angles is 180 degrees. The opposite angles are actually equal. In that parallelogram, if this is 60, this is also 60. Opposite angles are actually equal. Okay, which makes this also incorrect. Diagonals of a rectangle are always perpendicular to each other. Absolutely not necessary. Only in a square and a rhombus are the diagonals bisecting at right angles. So when the diagonals intersect at some point, the diagonals intersect with 90 degrees. That happens in the case of square. That happens in the case of rhombus, where all the sides are equal. It does not happen with a rectangle. It need not happen with a rectangle, which makes this statement also incorrect. I think this one everybody should have had no difficulty in. To find how much grass there is in a field, we need to calculate its perimeter. Obviously, no. To calculate the grass that is there in the field, you need to find the area. So, everybody clear on why all the 7 statements so far are actually incorrect? So, the actual correct answer should have been just this one, that is statement 8. Only 34% of us said statement 8. Alright, so make sure you pay attention to I hope you guys have noted down how many of these statements you got wrong, how many statements you got right. Please do that at this point before I move to the next slide, because we're going to come back to this. Based on where we faltered, we're going to categorize ourselves into specific groups. Everybody with me so far? Don't put in answers now, man. No point. Let me end that poll just in case. All right, good. So now let's discuss the next set. So yes, let's remove this and let's come to the next poll. Let me bring in the answers for this one as well. You guys can see how we polled. So you guys would have noticed an architecture here. The first set of questions, every statement was incorrect. None of those statements were correct statements. Here on the other hand, I pretty much gave you everything as a correct statement, right? Let's go through this also very, very quickly before I get into the main aspect. Diagonals of a parallelogram may or may not be perpendicular. Absolutely. In a square or a rhombus, they are perpendicular, but in a parallelogram, not necessary. So this is correct. Opposite sides are parallel and equal. Correct. Diagonals bisect each other in all parallelograms. Also correct. The diagonals may not be equal, but they bisect each other. Whether it is a parallelogram, whether it is a rhombus, square, rectangle, doesn't matter. In all these quadrilaterals, the diagonals bisect each other. So this is also correct. Diagonals of a rectangle are equal in length. Yes, also correct. 2 diagonals of a square divided into 4 congruent triangles. Absolutely correct. In a square, technically every side is the same. All the angles are 90 degrees. You have absolute symmetry. Each of these triangles are congruent. It is also correct. A diagonal of a square divides it into 2 isosceles triangles. Also correct. Each of these triangles would be isosceles. This hypotenuse is common. These sides are the same. Those are 2 isosceles triangles. Diagonal of a set. Yeah. Options. Question. Statement 7. Abhijit, I agree with you. I think there is a small error here. I should have pointed that out. This should not be paving material. This should be fencing material, and this should be fencing. So if anybody wants to change your answer at this point, I can totally understand. Imagine instead of paving material, statement 7 says to find how much fencing material is needed to lay a fence around a lawn. Then it would be perimeter, right? I think because of paving material, you thought about area. Then it's perimeter, absolutely. So I think this should have been made as fencing material. I'll note that down for next time. But your point is correct, Abhijit. Yeah. Volume is required, but what you have to calculate is the perimeter. Then you probably require the cost and all those other things eventually. But end of the day, from a perspective of what you need to, whether it's area or perimeter or whatever it is, geometrically you have to calculate. You need to calculate perimeter in those cases. All right. The keyword is around, absolutely. So some of you figured this out even without the confusion regarding paving and footpath. But otherwise, are we clear about how this one is? Sixth statement again, of course. If you take a square, this is a square, right? Let's say this is phi, this is phi, this is phi, this is phi. Square is 90 degrees. It divides it into 2 isosceles triangles, right? This is one isosceles triangle. What is isosceles triangle? 2 sides are the same, one side is not the same. Here, this side, it's the hypotenuse, it would be phi root 2. Right? I think the audio should be fine at this point. You can let me know if my signal is coming through, so you should be able to hear me. But To answer that question again, can you guys hear me now? Let's do a quick poll because a lot of you have mentioned this. Let's do a quick poll. How's the audio? Can you hear me at this point? Okay, wait. Wait, I haven't started talking yet. Just give me a second. Can you guys hear me at this point? Now you should be able to hear me. Now you should be able to hear me. So those of you who put, I think at this point you should be able to hear me. Perfect. So there was just a brief second where I did get lost. So I was looking at that. Thanks a lot. So I was explaining statement 6. Essentially, come back to this diagram. This is a square. If you make one diagonal here, these are two isosceles triangles, right? Two sides of 5 units each, and their hypotenuse is some 5 root 2 hypotenuse, right? So isn't the diagonal of a square dividing it into two isosceles triangles? Absolutely. So again, my point here is not to delve into these statements too much, but just to let you know about each of these statements. And these are statements that you should not have to figure out in the exam. If on the GMAT exam, in a question, you're not able to remember immediately that the diagonals of a square bisect each other perpendicularly, then you're losing time. Those are things that you should have in your mind. That's why those are conceptual points. Okay. Ravi, the idea is even a rectangle is an example of a parallelogram. So when a parallelogram is actually a rectangle, in that case it is perpendicular. So every parallelogram is not a rectangle, but every rectangle is a parallelogram, right? Opposite sides are parallel to each other. So a rectangle is an example of a parallelogram where the diagonals will bisect each other at 90 degrees. I hope that gives a little bit of clarity on this. So that's why the may or may not be. Even for rhombus, actually, yeah, even for rhombus, technically rhombus, yes, you're right, rhombus also has a 90 degrees aspect. It's just that the sides are equal. It's just that each and every side is the same, but the bisection happens at 90 degrees. Bisection of the diagonals happens at 90 degrees. The intersection happens at 90 degrees. Clear? Square and rhombus, they bisect at 90 degrees. Annie, that's why. Annie, hold on. That's exactly why we are getting into this point. The next slide. We are going to explain all of this in a way that you can retain this. You have to, obviously, you have not touched geometry since school, or maybe since college. Unless you're a mathematician, probably not. It's been a while. Even for me, it's been two decades, honestly. But that's the point. You have to learn some of these things, right? You have to spend that time and energy learning these things so that these aspects don't take your time on the GMAT, because these are the conceptuals. We are not even getting to the hard level questions. These are core concept. You should know how to calculate the area of a trapezium. That should not be something you are thinking about in the exam. If you're thinking about that in the exam, you're losing precious time. It's as simple as that. So there are some things that you need to know. So we're going to provide all that now. Okay. So those of you who, now let's do a little bit of quick grouping. Those of you who got everything right, you understood that in the first statement, in the case of the first set of statements, statement 1 to statement 7, all of them were not true. Or in other words, 0 out of 7 statements were true. Only the 8th statement was correct. So 0 out of those first 7 statements were not true. In the second, all 7 out of those 7 were technically true. If you chose perimeter, that's okay. That I'm okay with for that 7th one, but otherwise it's okay. If you got everything, essentially, if you got everything correct, you are in group A. Anybody here in this group A, which I'm talking about? Some of you might be there. Absolutely. So if you got everything right, you're group A. If you got some things right but not everything, you will be in group B. So 0 out of 7 is group A. I mean 0 out of 7 and absolute 7 out of 7 is group A. But if you are that person who got either 0 correct, 0 to 7 or 1 to 7 or 2, or in other words, maximum 2 mistakes in the first set and anything greater than equal to 3 in the second set. Exclude the one use case, that is 0, 7. If you're already in group A, exclude that use case. So anybody here in group B where you got maximum 2 things wrong in statement 1 and you chose something that is either 3 or 4 or 5 or 6 or 7 in the second group? Perfect. So you guys are in group B. Everybody else, you guys are in group C as far as I'm concerned. So why am I saying this? Because this is feedback on your current conceptual ability. So if you are in group A, you guys are already rock solid in quadrilaterals. I won't say all of geometry, but today's discussion, you guys are rock solid in all things quadrilaterals. If you are an e-GMAT student, you typically do not have to go through the concept files. You can move directly to the next set of activities, that is process skill. Even if you're not an e-GMAT student, this means that you can prioritize your time elsewhere. You don't have to spend that much time going through these concepts because you're crystal clear on it. That's feedback for you, for everybody here. Okay. Now, if you're in group B, there are some gaps. You know some of those things pretty well, most of those things pretty well. There are some gaps. We are going to discuss process skills. I'm coming to it. Hold on. So if you're in group B, you have some small gaps which you have to go through. So typically, if you're an e-GMAT student, the system will give you feedback. Okay, these are the concepts that you need to go through. You should go through those. Whichever statement you went wrong, for example, if you are not sure about the rectangle aspects, the bisection at a perpendicular bisection that happens, or rather square perpendicular bisection that happens in square or rhombus, then you should kind of look at the properties of square and rhombus. Make sure square and rhombus, all the properties are well known to you. Okay. But otherwise, you guys may be clear. You can go directly to the next aspect. If you are in group C, then you need to start from scratch. You need to build conceptual clarity from step 1. All right. So now very, very quickly, what we're going to do is we're going to kind of understand what it takes. What are those conceptual gaps that you need? What are those conceptual elements that you need to know as far as quadrilaterals is concerned? All those things we're going to discuss right now. Okay. So if you guys have noticed, what we have done is fundamentally a particular algorithm, what we have executed here. Essentially, we started by making you solve GMAT questions, and then we gave you some conceptual questions. By solving GMAT questions and conceptual questions, we got a good understanding of where you stand right now, right? Whether you actually need conceptual guidance or are you already great in this particular concept. This is kind of the architecture that Quant 2.0 actually has on e-GMAT. So any particular topic that you take in Quant right now, nobody starts off with concept. We always start with a diagnostic quiz. The first diagnostic quiz that you see here, it is actual pure GMAT style questions. It will tell you if you're able to do that well, then you have absolutely no concept issues, you have absolutely no process issues. And I'm going to discuss what process are in a bit, okay? But at this point, the audio is working, man. My network is pretty good. So if you do well in the first quiz, then your concepts are rock solid, your process skills are also rock solid. But imagine if you scored, let's say 30% in only 30% or 40% in that first quiz, GMAT skills quiz. At this point, you still don't know whether the issue is that you don't know your concepts or the issue is that you know concepts, but you're not sure about how to apply those concepts in a structured way. That's where the second quiz comes in. The minute you take the second quiz, if, for example, in the second quiz, you scored 90%, maybe you scored only 30% in that GMAT quiz, but in that concept quiz, you scored 90%. For me, that tells you that, hey, this person may have struggled in the actual GMAT style questions, but his concepts are crystal clear. So you don't need to work on concepts. You need to work on your ability to apply those concepts in a very streamlined fashion. That's process skills. Now, on the other hand, if you scored 30% in the first quiz and you scored, let's say, 40% in the second quiz, that tells me that, boss, your concepts itself is not strong. You have to first work on your concept. So do you guys get an appreciation for the architecture at play here. This is kind of what we have modeled this session also on, but it's also how the course is structured. I hope this gives you a little bit of glimpse into how quant really works, because it tells you, is it a concept issue or is it something else? Okay. Now, do pay attention to this slide. This is all the theory that you need as far as quadrilaterals are concerned for today. Okay. So as far as GMAT is concerned, these are the various quadrilaterals that we typically see. You have trapezium, parallelogram, rhombus, rectangle, square. Now let's talk about what we can say about the sides. Trapezium, the only thing you know is there are two parallel sides. So there are two sides that are opposite and parallel to each other. Everything else we don't know anything about. So here this AB is parallel to this DC. That's all I can say. There is one pair of opposite sides which is parallel to each other. That's it about trapezium. When it comes to parallelogram, you have two pairs of opposite sides. They are parallel and they are equal, right? Also check your connection, because if you are coming here with a mobile connection, then that will keep cracking briefly, right? Be very, very sure about that. Okay. It also comes down to your connection, guys, not just my connection. My connection, of course, can break once in a while, but I have Wi-Fi here. All right. So let's continue. Parallelogram, two pairs of opposite sides. Both pairs of opposite sides are parallel and they're equal. So, or in other words, this AB is parallel to this CD, this AD is parallel to this BC. Very simple. Rhombus, the difference is a rhombus is also a parallelogram, but all the sides are equal. Fundamentally, a rhombus is to a parallelogram what a square is to a rectangle. It's the case where all the sides are equal, right? So in the case of a rhombus, all the sides are equal and the opposite sides are parallel. You guys know this. Let's come to rectangle. Rectangle, also very clear. Opposite sides are parallel. Opposite sides are equal, but adjacent sides are not necessarily equal. A rhombus is usually not a square. A square has 90 degrees. A square and a rhombus both have both have all sides equal, but that angle need not be 90 degrees in a rhombus. In a square, that angle is 90 degrees. That's a very, very key difference. That's pictorial, don't go by that. All right. But fundamentally, in a rhombus, you need not have 90 degrees. That's something you need to understand. But in a square, all those sides are 90 degrees. I mean this internal angle. All right. So far, so good. Let's get into angles. So now that we are talking about angles, let's get into angles. With trapezium, there's nothing much you can say about any of these angles. So no real rules here. But with parallelogram, as we already discussed, the opposite angles are equal. So if this side is 60 degrees, this angle is also 60 degrees. Keep that in mind. The adjacent angles are in fact summing up to 180 degrees supplementary, as one of you pointed out. In a rhombus also, just like a parallelogram, the opposite angles are equal. So both in a parallelogram and a rhombus, the opposite angles are equal. So when you are learning these things, you should see for what's common and what's not common to anything that you read. That's the way you retain this information in your head. So Annie had asked, like, how do you retain all this? See for what's common, see for what's not common. Now, for example, parallelogram, rhombus, both of them have opposite sides parallel to each other, but that angle need not be 90 degrees. That's something that's common to them. Both of them have opposite angles equal, but that angle need not be 90 degrees. Another aspect. How is it different from a rectangle or a square? In a rectangle or square, every single angle is 90 degrees. So far, so good. Now let's talk about diagonals. This is where it gets very, very interesting. Again, with trapezium, there's not much insights that you can draw. Okay, but with parallelogram, remember this thing. Whether it is parallelogram or rhombus or rectangle or square, or in all these cases, the diagonals bisect each other. Charles is asking a question, what is a diagonal? Charles, this thing that I just drew is a diagonal. This is diagonal 1, this is diagonal 2. You're connecting the opposite vertices. That is diagonal. Okay. These are the terms that you should have an absolute death grip on before you go to the exam, okay? Because otherwise you'll be wondering what that is. You cannot do that on the exam. Okay? So parallelogram, rhombus, rectangle, square, it doesn't matter. In all these cases, the diagonals bisect each other. Now, bisect means it divides it by 2. Now, for example, let's draw a simple example. This is a diagonal. This is another diagonal. Bisect by 2 means that if this is A, this is also the same. This is equal to this. Something gets bisected means something gets divided into 2 equal parts. Lost audio? Okay, just give me 1 sec. Hey guys, so now you should be able to hear me again. At this point you should be able to hear me again. Perfect. So yeah, it fluctuated, it went off for a while, but I'm back. You guys should be able to hear me crystal clear again. So bisection means dividing something into 2. A 10 centimeter diagonal, this other diagonal is bisecting it into 2 parts of 5 centimeter, 5 centimeter. Bisection is clear? Trisection would be dividing into 3 equal parts, but though we don't see that typically. But bisection means it divides it into 2 equal parts. So fundamentally, parallelogram, rhombus, rectangle, square, in all the cases, what's common? The diagonals bisect each other. What is not common? In the case of parallelogram and rectangle, the diagonals are not equal to each other. One diagonal may be 10 centimeters, the other diagonal may be only 9 centimeters, not necessarily equal for both parallelogram and rhombus. But the minute it becomes 90 degrees, or in other words, the minute you're talking about rectangle and square, the diagonals not just bisect each other, they are both equal also. That is something that's common. So parallelogram, rhombus, diagonals are not equal, but they bisect each other. Rectangle and square, diagonals bisect each other, they're also equal. Now, there is something else that is interesting about diagonal that's common to square and rhombus. So in both cases where the sides are the same, or in other words, all the sides are the same, in both square and rhombus, the diagonals not just bisect each other, they bisect each other perpendicularly. Or in other words, this angle is 90 degrees. This is common to square and rhombus, where all the sides are equal. So when you're reading this, I don't want you to just by heart this. I want you to think about how some things are common, some things are not common. When you're doing that actively, you'll be able to remember all this information. Okay? Let's talk about the easier aspects, that is area and perimeter. This you have to know. So when you're talking about trapezium, what is the area? Half into sum of parallel sides into distance between parallel sides. You should know that. For parallelogram, base into height, perimeter is the same as rectangle, 2 times length plus breadth. What is area of rectangle? Length into breadth. What is area of square? Side square. What is perimeter of square? 4 times s. You should know this. What is the area of a rhombus? Half times the product of the diagonal lengths. AC is the diagonal, BD is the diagonal. So this is diagonal 1 and this is diagonal 2. These things you should keep in mind because you don't want to spend time on this on your exam. It's rare, honestly, but you should know. It's still part of the syllabus, you should know. We mostly see the other stuff, but yeah. So are the concepts clear? These are the things that you need to know. When we will share the PDF with you, when you have the PDF, I want you to take some time understanding these aspects. See how we connected parallelogram, rhombus with rectangular, square. What is common, what is not common. In what cases are you observing what trends? If you internalize that, this stuff will be stuck in your head. You don't have to retrieve it taking time. Okay? This is all the concept for today. Now we're going to discuss what we call as process skills. Now, some of you asked about what do I mean by process skills. Now, on the GMAT, what you have observed is we are not typically looking at your question is not going to ask you, you're not going to get a question which says, hey, this angle is 60 degrees. What is this angle? Have you ever seen a question like that on the GMAT? The answer is no, right? The GMAT is always going to test you on a higher level of application. You're never going to get pure, factoid kind of questions, typically. So having your conceptual knowledge is just the base of it. Above the concepts, there is something else you need to know. That's what we call as process skills. Some of you are already doing this very well. Those of you who are very strong in quant, you guys do this unconsciously, but fundamentally, these are what those skills are. I'll give you an example. In those questions that you solved, say that last data sufficiency question that you solved, it talked about a rectangle, it talked about having that border, but it was given to you in words. You converted those words, you translated those words into a visual, into a picture that you could understand. That is fundamentally translation. Or in advanced topics or word problems, you're given some sentences. Based on these sentences, you're arriving at mathematical relations. That is called translate. Now, sometimes the question might be asking you for area of this border. It's only after you have that picture in mind, when you visualize, you can see that, hey, the area of the border, is it not big square minus small square? That skill is visualization. Now, sometimes you have a quadratic equation. You have to solve something like x square minus 5x plus 4. You have to simplify this to arrive at the value of x. That's another process skill. So these are all things that you know, but you don't know that these are the things that you're doing. These are all important skills, and a lot of times, even though your concepts are sound, you may go wrong because you're not applying one or more of these skills. For example, you might solve a quadratic equation. That quadratic equation will give you the answer, let's say minus 5 and 10. Now, you might think that minus 5, 10, both of these are correct answers. But, and again, a very big but, you might think that you've got the correct answer, but then you would see that. Can you guys hear me? Just checking. Am I audible to you at this point? Just to ensure. All right, perfect. So sometimes you miss out on this very important point. The question, while solving the quadratic equation, you might have arrived at minus 5 and 10, but the question would be, x is a side of a rectangle, for example. Can a side of a rectangle be negative? The answer is no, right? And therefore you should have rejected an option choice that talks about minus 5. If you're not doing that, you're not applying constraints. So fundamentally, process skills are those additional skills which go beyond your core conceptual knowledge, which you use to arrive from the question all the way till the correct answer. You do this, a lot of us who are already comfortable with math do all these things steps unconsciously, but you need to have an understanding that these kinds of skills exist. So that's what we have been doing. We have done our research and we've understood that these are the core skills that are actually employed to create GMAT style questions. Okay, so just a quick idea of process skills. At this point, here is a link that you guys can click. We've actually made videos on this to explain what process skills are. So feel free to click on that video. It will lead you to a playlist where we kind of discuss each of these process skills in detail. You'll have a far greater appreciation and understanding for these skills. All right, so shall we move on? We're going to do some questions now. So far what we discussed were the concepts. Through that last slide we kind of clarified all the concepts. Now the concepts are clear. Now we are going to work on process skills, all these aspects that are here. Everybody ready? Can I see a quick round of yes, just to ensure that the class is here? Perfect. That said, I hope you guys have clicked on this link for future reference. Now let's move into questions. So here's the first question for you, the next question of the day for you. Let's begin with still solving. Thanks for putting the link there, Shikhar. Absolutely. As you go through those things, you'll find that the GMAT is not testing you just on your conceptual knowledge. Again, why is this important? A quick reminder. A lot of us who have not studied quant in 20 years or 15 years, we sometimes think, hey, I just need to brush up my concepts and then come and sit for the exam. That works if all these aspects you're able to do automatically. Somebody who's really strong in quant, for whom these process skills are already bread and butter, no problem. You just need to revise your concepts, touch it up a little bit. But if you are not that person, just brushing off the concepts before the exam, 2 days before the exam, is not going to get you to Q50 or Q51 on quant, because the GMAT is not testing you on pure conceptuals. I hope this point is coming through. That's the reason we are emphasizing this aspect so strongly. GMAT in 2 days. All the best, all the best, all the best. So here's the next question for you. All the best. It's a very easy question, in my opinion. Zoo, always have confidence, man. It does not matter. Have confidence at this point. At this point, you should focus on your strengths. What you're good at, focus on that, deliver on that. Okay? Alright, folks, let's begin to get those answers in another few seconds for you. Alright folks, last 10 seconds. Four, three, two, one. And those who are stuck in still solving, it's a good time to take your best shot. Gut feel at this point. And then let's move on. And one. Alright. So I'm gonna end this poll. Alright, so how was this question? Not difficult, right? Should have been easy. Absolutely. It's easy, but it's illustrative of these process skills that I'm talking about. Once you know the concept, you still have to do some of these, demonstrate some of these skills to arrive at the answer. Now, let's understand, let's kind of get through this question. The minute you read area of square ABCD is equal to area of rectangle PQRS, immediately this should have come to your mind. So there is a square, there is this rectangle, right? Is it okay to draw? Absolutely. You should, in fact. For geometry is that one section where you should be putting pen to paper and drawing the diagram. After that, your downstream life is usually easier rather than keeping everything in your mind. Unless your mind is so well compartmentalized and brilliant that you can retain a lot of information, I always strongly recommend for geometry, draw the diagram. Okay, but essentially this picture has to start forming. Square of ABCD, area of the square, in other words, a square. This area, a square is equal to the area of the rectangle. What is the area of rectangle? We also know that A into B, right? So we know that these two areas are equal. Great, fantastic. Now, we are also given the length of the rectangle is 21% more than its breadth. Here is a quick question for you. What is the relationship between length A and breadth B based on this particular section? There is a relationship between length and breadth that's given to us. So which of these should be the correct answer? 4, right? 1.21. This is again another aspect that for those of us who are not extremely comfortable and familiar with quant and percentages specifically, I want you to get comfortable with this. The minute you see something is 21% more, you should be able to say that means it's 1.21 of B. If this is not coming naturally to you yet, you need to work on this. Okay, so what is it? Essentially, it is the length of the rectangle is 21% more. So it is B plus 21 by 100 into B, or in other words, is B plus 0.21 B. In other words, it's 1 plus 0.21, 1.21. This should not take you time. For those of you who are not that comfortable with math, if you're able to arrive at this immediately, you'll save those 2-3 precious seconds. Okay, so fine. You have a relationship between the length and the breadth with already given to us. That's great. Now what else is given to us? The areas are equal. Or in other words, if you can actually figure out, that means the area of the square is a square, the area of the rectangle is 1.21 B square, right? Why is it 1.21 B square? It's 1.21 B into B. It's still a rectangle, right? In other words, you will get a square equal to 1.21 B square. Till this point, everybody should have got this. Now, what is it that the question is asking us for? Ratio of perimeter of ABCD to perimeter of PQRS, right? What is perimeter of the square? 4S, right? In other words, we need to find 4S divided by 2 into A plus B. The good thing is, to find this ratio, all you have to ensure is everything has to be expressed in terms of one entity. If you can express B is already in terms of B, A, you know what A is in terms of B. A is nothing but 1.21 B. So A and B are very easy to express in terms of B. The only thing missing was, how do I express S in terms of B? For that, you found that you used the area. You got this. S square equal to 1.21 B square. So based on S square equal to 1.21 B square, what can you say about S? S equal to 1.1 B. In reality, please note, in reality, there are two there are two answers that are possible, right? For s square equal to 1.21b. What is the other possibility from a pure math perspective? Yes, from a pure math perspective, if s square equal to 1.21b square, you can also have the value of s equal to minus 1.1b. But this is where that constraint comes in. You're talking about the side of a rectangle. You're talking about this particular side of a square. It cannot be negative. It has to be positive. And therefore, s is definitely positive. The only possibility is 1.1b. So now you have each of these things, both the numerator and denominator, everything you can express in terms of b. So you should have been able to arrive at 220 by 221. So let me kind of broadcast the results because it's very interesting. This was a fairly easy question, but still there's only 56% of us who actually got the correct answer, which is B. Now, for those of us who did not get the correct answer, can you guys tell me where you faltered? Let's understand that as well. What is it that you are not able to do? Where did you go wrong? Couldn't conceptualize what formulas to use. That's interesting. Palvi, that's okay. That for me is okay. Over a period of time, you are going to build that ability. I'm pretty confident. Translate. Okay. So, what formula to use is based on what are the entities given and what are we being asked. We are given area of square. The minute you read area of square, S square should come to your mind. The minute you read area of rectangle, PQR, the minute you see area of rectangle, length into breadth, A into B should come to your mind. And then you're talking about perimeter. Square perimeter is 4S. The other one is 2 into L plus B. Akshay says, I didn't see that the quadrilaterals were square and rectangle. See, in your case, it's attention to detail. You have to read the question carefully. What is given, what is not given. But even for an easy question like this, it's actually easy, provided if I give you more time for those of you who are not already very strong conceptually also. But do you see where the improvement can come from? What are those steps that you can do better? See, with regard to geometry, the one thing I'll tell you is don't be afraid of doing the math. So a lot of us are afraid of getting into the nitty-gritties and doing these calculations or putting that formula. Don't be afraid. Just get into it. You will get the answer if you do it all systematically. Okay? But this is good. Shall we move to the next one? Or is there any other doubts here? If you put it in the Q&A, Anshuman is also here to help out with those. But I think it's pretty clear, right? Okay, so now let's move to a proper 700. We're going to go back to one of the questions that we tried. Okay, so you guys might remember this question. This is the one we started our day with. So before we get into this, let's talk about the correct approach for DS. How many of you are very crystal clear about how to do data sufficiency? There is a method to it, right? Yes. So for those of you who are not entirely sure how to go about data sufficiency, that's why this section is here. This is for all of you. See, data sufficiency, end of the day, if you look at the options, first let's look at the options. Let's come back here. Let's look at the options that we have. Right? Option A says the first statement alone is sufficient, but the second statement is not sufficient. Option B says statement B alone is, statement 2 alone is sufficient, statement 1 is not sufficient. First things first, you have to understand what each of these statements mean. Option C, let me give 1 second. I see a bit of a fluctuation, but yes, let me ensure that the audio is coming through. Can you guys hear me? Very quick show of hands. Can you guys hear me? Perfect. Yes, good. So statement 3 is the case where, hey, both statement 1 and statement 2 together are sufficient, but alone both of them are not sufficient. Option D is a very interesting option which says each statement as it stands is sufficient. If you take statement 1, through statement 1 also you can answer the question. If you take statement 2 through statement 1 alone also you can answer the question. Option E is the case where none of this work. Whatever combination you take, it's not going to answer the question. So here is a DS process for those of you who are a little confused about how to go about the data sufficiency. Pay attention, it's important. So the first important aspect I want you to remember is, in any DS question, don't jump directly to the statement. The question is giving you some information. First, process and analyze everything you get from the question. Try to identify what is it you need to do. That's the first aspect. Okay. I see that there's still an issue. Yeah. Let me try shifting this one. You guys should be able to hear me now. Yeah, I apologize. Today is a very odd day. I typically don't have so many audio issues ever. So it's a bit of a surprise today, but okay. Alright. So first things first, don't directly jump to statement 1 or statement 2. Spend some time trying to analyze the given information in the questions itself. That's step 1. Only after that you go to statements. Okay. And when you go to statements, let me close this. When you go to statements, think about it. If statement 1 directly gives you the correct answer, then you can eliminate options B, D, and E. Actually, B, C, and E should be, right? We're going to see this in action anyway, so I think we'll just go to this directly, okay? We want to see this directly in practicals, so let's do that rather than get confused here. All right, so I'm going to bring the poll for you. It's the same question that you guys solved earlier, so my assumption is that it should not take you that much time, but let's see. So here's the poll. Let me reopen this. Let's again start with still solving, guys, before you begin. That way it becomes very, very clear. So while you guys were solving that question, I switched my internet. I have multiple Wi-Fi's here, so I hope the audio issues will not trouble us from this point on. I still see a lot of you are still solving this. Let's take another 15-20 seconds. Ideally, the second round it doesn't take as much time, but let's see. Let's try to wrap this up, folks. All right, so most of you are done. Let's take another 10 seconds for this, and then let's get to the next steps. All right, so 3, 2, 1, and I'm gonna end the poll here. Take your last shot for those of you who are still stuck, and end poll. All right, so a quick comparison in terms of what percentage of people got this right last time versus what percentage of people got it right this time. So last time around 38% of us had got the right answer, which is option C, by the way. This time around 50% of us have got the right answer. So I'm happy to see that improvement. So any of you here who got it wrong the last time and got it right this time, let me know your thoughts. What changed for you? C is the correct answer. Yes, absolutely. For those of you who are wondering, let me broadcast the results also. So last time around 38% of us have got the right answer. This time the 38% has come up to 50. For those of you who did not get C last time and got C this time, what changed for you? Always happy to see when there is improvement. So that's great. And for those of you who are still a little confused about how to go about this, by the time you're done with this, you'll be very, very clear. All right. Got adapted by the passage of time. Some of those things definitely helped. So think about what is being asked in the question. The cost to fence a rectangular plot. So it's not the area of the plot. It's the perimeter, right? You can understand that it's all about the perimeter. There is a rectangular plot. You want to put a fence around this, right? So that talks about perimeter, not area. I'm giving you the answer for this one because I think we have discussed this time and again at this point, right? Everybody clear that the relevant geometrical aspect here is perimeter rather than area because it's about cost to fence the rectangular plot. Abhi says yes, but rest of you just want a quick word. Make sure that if anybody is not clear, I want to know. That's why. Perfect. That's good. So think about it. So what is the cost of, you have $20 per meter. So simply put, your cost is this rate of 20. It's per meter, right? Into perimeter, right? It's as simple as that. I want you to make sure you do this analysis before you jump into statement 1 or statement 2. So fundamentally, you realize that what matters is that perimeter. So you need to find that perimeter, right? Essentially, your cost is just perimeter into 20. Perimeter is 2 into a plus b. So if I ask you the question, what is it you need to find so as to be able to answer this question? That is what you need to understand. What is it that you need to find in order to answer this question? To find the cost. Because the rest, as you go through the statements, your mind is focused on that. Trupti says A, comma B, which is also correct, but it's not necessary that I find A, comma B. If I find A, comma B, or in other words, A and B, then I will be able to find A plus B. Eventually, I have to find A plus B. So if I find A and B, that enables to find A plus B, or I may not find A, as Abhi says, I may not always be able to find the individual value, but if I still find their sum, even without finding A and B, if I find A plus B, then also my purpose is served, right? So essentially, you find A plus B, you crack the question. That's what I want you to keep in mind as you go to statement 1. Now let's look at statement 1. Length of the plot increased by 10 meters. The area of the plot increased by 700 square meters. So which of this is correct? What information does this statement provide? So you guys would have done some analysis on statement 1. What is it you can arrive at if you do the math? Ravi says B equal to 10. Value of width, Abhi says the same. Absolutely right. If you guys solve this, if you guys solve statement 1, you will be able to arrive at the actual value of B. Anybody struggled here? Anybody was not able to find the value of B from statement 1? If anybody struggled here, this section is for you. So essentially, length of the plot increased by 10 and area of the plot increased by 100. Area of the plot earlier is AB. Area of the plot now should be again A into B. In this case, it's A plus 10 into B. If you just put it as an equation, new area is original area into plus 100, you will be able to solve for this and get B equal to 10. Anybody struggled with this, or everybody got this? So it's fairly straightforward, but fundamentally you have to also observe what you got. You got the value of B, but you want A plus B. If you also got the value of A, then this statement 1 would be enough. But have you got the value of A? No, right? You only got the value of B. Unfortunately, you did not get the value of A. and you still don't know what is a plus b, which means statement 1 is not sufficient. Because if you want to find the cost, you need to find the perimeter. To find the perimeter, you need to find a plus b. You only found b through statement 1. You did not find a, therefore you could not find a plus b. Simple. Everybody clear with statement 1? So can I move to statement 2? Just to be on the safer side. Abhi says yes. So that's all statement 1 is about. End of the day, it gave me b, but it's not giving me a. Therefore, I'm not able to calculate a plus b. Afrida, think about it. Can you find the value of a just based on this? How will you find the value of a based on this? You might think you might substitute it back in the original equation, but that is circular logic. If you substitute it back, all your terms will get cancelled. You will not have a or b. For example, if you substitute b back into this original equation, you will get 10a plus 100 equal to 10a plus 100. All terms will cancel. You will still not have found a. A is still a question mark for you. Exactly. So don't assume that, hey, I can just put this value here and find it out. You arrived at b using the same equation. You cannot just put it back in the same equation and find it out. If you had some other equation, some other relationship between a and b, then you'll be able to find a. But it's good. These are the kind of mistakes that we will sometimes make if you're not careful. Now let's look at statement 2. Statement 2, length decreased by 10%, width increased by 10%. So we have already discussed you need absolute comfort on percentages. So what is the new width? Very quickly. Absolutely. Width increased by 10%, right? So 1 plus 10 by 100 into, b plus 10 by 100 into b, that becomes 1.1b. So essentially what this boils down to is this. Length decreased by 10%, width increased by 10%, perimeter decreases by 5%. Or in other words, this is the original perimeter, this is the new perimeter. Now we are given that the new perimeter is less by 5%. In other words, it's original minus 5 by 100 into original. It is 90.95 into original. So if you put these things together, you should be able to arrive at this. Essentially, you will get a equal to 3b if you work out the whole math of it. But fundamentally, you see what the problem is? You only arrived at a relationship between a and b. Why do I have them equal to each other? Because I am told that old perimeter increased by 10%, decreased by 5% to give new perimeter. So this equal to 95% of this. Rather, the other way. The equation comes from what is given to us, right? Perimeter decreases by 5%. So old perimeter is 2a plus b. 95% of the 2a plus b is the new perimeter. That is 2 into 0.9a plus 1.1b. Charles, I hope that is clear. That's where this comes from. You have to put pen to paper and do that math. But the point is, once you do that math, I hope you guys realize that all you get is a relationship between a and b. But you still don't know what is a or what is b. You don't know what is a plus b. Right? We still don't know those aspects, right? I'm not sure which point you want me to repeat, but if you put it in the Q&A, we'll help you, Akshay. Don't worry. Anshuman is also here to help out. But is this clear? Fundamentally, if you put in the information from statement 2, all you're getting is a relationship between a and b. A equal to 3b is something you will get. But does that tell you anything about a plus b? Do you know what is a plus b based on this? The answer is no. Is this clear? Very quick show of hands. Akshay, even for you, think about what we just saw, right? Length of the plot decreases by 10%. Length of the plot decreases by 10%, 0.9a. Width of the plot increases by 10%, 1.1b. So therefore the new perimeter is this, 2 into L 2 into L plus B, right? So here that is 2 into 0.9a plus 1.1b. Old perimeter is 2 into a plus b. What do I know about relationship between perimeters? Decrease by 5%, right? So that I'm putting that in, and then I'm solving whatever I'm able to solve. Perfect. Then I'm again stuck with a relationship between a and b, but I have no idea what is a, what is b, or what is a plus b, and I don't know what is a plus b, which makes this not sufficient. So fundamentally, statement 1 was also not sufficient, statement 2 was also not sufficient. Now we have to check for the combination. What if both of them are sufficient together? That we have to check, right? So so statement 1 gave us the value of b as 10, correct? What happens if you substitute this value of b in statement 2? You don't even have to do the calculation. In a data sufficiency question, you don't even have to do this calculation. Can you not immediately say that if the minute I put in b, I can find out a also? Abhi has calculated it. Abhi has told us a equal to 30, but even without doing the calculation, you can figure it out, right? You had an equation, you had a relationship a equal to 3b. I'm saying if I take information from statement 1, I know the value of b. That means I also know the value of a now. Now that I know a and b, I can calculate a plus b. If I know a plus b, I can calculate the perimeter, I can calculate the cost. I don't even require it to calculate. I'm not required to calculate, but you know that it can be calculated. Correct? Or in other words, statements 1 and 2 together can give you the solution. They are sufficient. 2 equations, 2 variables, absolute, exactly. That's the point, which makes option C the correct answer. So is this clear to everyone at this point? Perfect. So now let's move on. Let's go to the next question. Let's go to 1a, and 1a, how is it that if we discuss 1a, I don't know if you guys did this question again, but let's discuss this never the same. So what happens in this case? Perimeter of the plot increases by 50%, right? What does statement 1 say? Length of the plot increased by 10 meters, perimeter of the plot increases by 50%. So when length of the plot increases by 10 meters, what does that mean? A becomes a plus 10, right? When a becomes a plus 10, perimeter increases by 50%. Or in other words, perimeter, earlier if the perimeter is x, increased by 50% becomes, perimeter becomes 1.5x. So far so good. But what is the new perimeter as per the new length? 2 into L plus B, right? Isn't working with fractions easier than decimals? Honestly, it depends on you. For these kinds of percentage calculations, you could use both ideally. I won't say that one is easier than the other. I find this very easy if I have to, calculate with regard to percentage. So it's a matter of your faith, I suppose, whether you're a decimal person or a fraction person. But fundamentally, you should be able to do it fast. That's all I care about. So that's there. All right. So what happens when you apply this? What is the new perimeter? What is the perimeter? This is a rectangle, right? So what is the perimeter of the rectangle? 2 times a plus b. Here a has become a plus 10. So it becomes 2 times a plus 10 plus b. Simple. And what is it given? The perimeter is increased by 50%. So old perimeter is 2 times a plus b. It has increased by 50%, it has become 1.5 into 1.5. If you solve this, how many of you observed that you were able to solve for a plus b at this point? In this case, you don't have to calculate, right? You're able to get L plus b, or a plus b rather, even without doing anything else. You don't have to calculate a and b separately, but you're able to get a plus b. Absolutely. So what this means is in your variation 1a, this is more than enough. you're able to solve it using the given statement 1. Now let's move to statement 2 because that's where things get interesting. If the length of the plot decreased by 10%, width of the plot increased by 10%, this is exactly the same as the first case. Again, you will arrive at a relationship between A and B, but again, just with the relationship between A and B, you have no idea what is A plus B. So just like in the last case, statement 2 is not sufficient. So in the variation question 1A, what is the correct answer? Option A, because option A says statement 1 is sufficient, statement 2 is not sufficient. So at this point, everybody is clear. Can we move to the next set of questions because it gets very interesting now? Anybody has any doubts? Perfect, I like to see that. All right. So very important learning. Don't go in with this blind assumption that, oh my god, I need to calculate A, I need to calculate B. For this question, all you had to calculate was A plus B. Whether you got A or B individually, nobody cares. If you're getting that, fantastic. But you don't have to. 2 minutes for all these, the time pressure feels immense. Once you get used to it, actually no. So even in this batch, for the same questions, I saw people getting the correct answer within the 2 minutes. So with some of us were able to get that even within 1 minute. So it's a matter of practiced application. You should get comfortable with all this. So think about all those small steps that you're doing, which are taking time today. For example, if you have to remember that perimeter of a rectangle is 2 times L plus B, you're wasting time. That should come to you automatically. So once you have crystal clear clarity on those things, then you proceed systematically. These things are actually easy. It will be, all these questions are doable within 2 minutes. I have seen proof of concept in this room. Among us, there are people. So it's doable. Don't worry about it. So let's do another question. So before I bring this question, let's again do still solving, just in case. Here's question 2. Here you go. Let's solve this. Let's get this question. I hope the DS question was useful because you can see in terms of approach how we are going about things systematically. All right, so here's the question. All right, folks, I see some of you are done. I'm still waiting to see the rest of you. All right, folks, most of you are done. Let's take another 10 seconds. 5, 4, 3, 2, 1. And this is your time for anybody who wants to try their gut instinct if you're not yet solved the question. All right, so and 1. So let me pause this at this point. Most of you have got the correct answer. Like 60% of the batch has got the correct answer. So I'm going to broadcast the results. C is indeed the correct answer, but let's again apply those right processes which go beyond the concepts of quadrilaterals and understand why C is the correct answer. So, how was this question? Was it easy? Was it difficult? Quick show of hands. Nasha found it difficult, so we're going to clear the clutter. Ritvik found it easy. Time intensive, conceptually easy. So what Dhaval says is actually a very important point if you ask me. A lot of geometry can be a little more time consuming than some of the other concepts. So for example, most number properties questions, if you ask me, they won't take you much time once you reach that level of mastery. But geometry can take a little bit more time because that's the nature of the beast itself. So you should also not shy away from doing that work, or never get into a geometry question thinking, oh, this is going to take time. No, just methodically do your work, results will follow. Okay, so this is also, as per me, it's an easy question. These are all fundamentally building those process skills. So these are not those tough questions that we started our day with. Okay, it's a combination of geometry and quadratics, absolutely. So what do we know? Length of a rectangle is 9 centimeter more than its width. So the minute you read this, your brain should start forming this rectangle in your head. If width is b, length is b plus 9, right? And the area of the rectangle is 90. Fantastic. You know the area also. What is the distance between the center of the rectangle and its vertex? So here is a quick question for anybody who is not 100% sure. Which of these four diagrams is the correct one you're looking for? Center of rectangle to vertex. Everybody is clear, it's C, right? Center of the rectangle is this, one of the vertices is this, and it's a rectangle. The distance from all vertices is absolutely the same, doesn't matter. So we are looking at this distance. That should be clear to everybody. Perfect. Because if that is not clear, if this initial visualization is not clear, then the rest of your question is going to go for a toss. Anybody who was not able to figure this out, that this is what is being referred to, I'm assuming that you are able to, but if that's not the case, then your primary skill is translation. You should have been able to translate what this means into this. So let's get into it. So what do you know about rectangle? So the approach is, the minute you figured out that, hey, we are dealing with a rectangle, your brain should immediately remind you, okay, what are those properties of the rectangle that are super important here? So what do you know about rectangle? All these angles are 90 degrees, right? That's one thing you know. What else do you know? Bisection happens at the diagonals, right? Or in other words, AO is nothing but half of AC, right? This AO is nothing but half of this AC because diagonal gets bisected, right? Everybody with me so far? Distance equal to half of the diagonal. What you need to find is half of the diagonal. And you also know that this is a right angle. So what can you say about triangle ABC? All this thought process begins when you realize that you're dealing with a rectangle. If you don't focus on that, you don't know. Absolutely, it's a right angle triangle. So in a right angle triangle, if you want to find that this particular AC, how do you find that? Whether you want to call it Pythagoras or by some more Eastern Oriental name, it's another thing. But everybody knows the theorem, right? Pythagoras Theorem. All I have to find out, to find out AO, first I should find out AC. To find out AC is simply P square plus Q square, right? Pythagoras Theorem. Then AO is nothing but AC divided by 2 because rectangle diagonals bisect each other. So everybody is clear with the approach that what is it that you need to do? Very simple, right? Anybody who struggled to reach this point, that hey, all I need to do is find out this P square plus Q square and then divide it by 2 to get the answer. Simple? Just to ensure that everybody is on page, because this is easy for a lot of us, but for some of us do not come from that background where we spent a lot of time doing mathematics, right? So some of these things which seem very intuitive for the rest, it's not actually intuitive. It takes effort to get there. So that's why we're going through this in a little bit of detail. So simple, all I need to do is find P square plus Q square and then divide it by 2. Yeah, as Abhi points out, find the root before you do any halving. But anyway, let's get into that. So to do that, first you need to understand what is P and what is Q, right? What is given to us? Area of the rectangle is 90. What else is given to us? If Q is, whatever Q is, P is nothing but Q plus 9, right? That's also given to us. Length of the rectangle is 9 centimeter more. So what is the area of the rectangle? Q plus 9 into Q. Am I correct? And as Abhi correctly pointed out, it leads you to a quadratic equation. So this is where your knowledge of algebra comes in. The algebra we learnt in school, nothing complex, it's quadratics. So if you solve for this quadratic equation, Q square 9 plus Q into Q is equal to 90. Or in other words, Q square plus 9Q minus 90 equal to 0. If you solve that, you will get two values of Q, minus 15 and 6. At this point, it should be crystal clear for you why we are rejecting minus 15. Why is it we are rejecting minus 15? We are saying that minus 15 is not possible. Why? Cannot be negative. So here, because it's geometry, it's referring to a side, you know it's positive. You know it has to be positive. In another question which is not geometry, where it can be negative, don't forget that minus 15 is also a possibility. So you have to solve the quadratic equation. It gives you two answers. So you will get Q equal to 6. If you got Q equal to 6, what is P? Q plus 9. That's why P equal to 15. Now you found out P, you found out Q. All you had to do is use Pythagoras theorem, find this hypotenuse. What is that hypotenuse? P square plus Q square. That root of hypotenuse rather. So if you do this, you're getting 261. So you have to find that hypotenuse, that is AC, root of 261. So what is AO? Root of 261 divided by 2. So at this point, you got root of 261 by 2. What I would do, how I would solve this is, now I will go to the option choices. Because sometimes the answer choice might have root 261 by 2 directly. In that case, I don't need to simplify this, right? So whether I need to simplify this root 261 further, I would actually take a quick peek at the answer choices. And that's when it becomes very interesting. When I look at the answer choices, I can see that it is not in terms of root 261. I see root 13 and root 29. So rather than find out what are those factors of 261, what is the easy way to do it? Test for 13, test for 29. Is 261 a multiple of 13? It's very easy to check that, right? Why? 13 into 2 is 26. Or in other words, 13 into 20 is 260. If 260 is a multiple of 13, can 261 be a multiple of 13? That's the quickest way to reject both A and C. The minute root of 261, I went to the answer choices. Then I looked at 13. Then I figured out, hey, 261, it has nothing to do with 13. I could immediately reject A and C. A and B rather, and I focus my attention to root 29. So 261, is it a multiple of 29? It is, right? 29 into 9. So now I know how to arrive at the correct answer from here. I found out root 261 is root of 29 into 9, or in other words, root of 29 into 3 square, because 9 is nothing but 3 square. So root of 3 square means you can take the 3 outside. So you are fundamentally getting AC equal to root 3 root 29. And please do not choose the answer 3 root 29. You have to remember that what you want is not AC, what you want is AO. So you have to divide that by 2. So for some of you who chose that option D, you did all the hard work and then you forgot to divide by 2. For those of you who probably chose option D, I think I see 2 of you here. So for those of you who chose option A, B, E, or even E for that matter, I don't see anyone. Is the solution clear? How the answer is root 3 root 29 divided by 2. So there are some lessons here, but fundamentally everybody's clear about 3 root 29 by 2. The solution should be clear, right? Louise says yes, Ragini and others are typing. Vaishnavi says yes, Abhi says yes. Good. If there's any doubt, put it on the Q&A. I'm going to move on. But if there's any doubt here, any of you are still a little on the fence, you're not sure about it, just put it on the Q&A. We'll help you out. It's slightly calculation intensive. But that's why I use the option. Well, my first point of concern is, should I even simplify root 261? Then I looked at the answers choice. It seemed like yes, I have to do some kind of simplification. Then I eliminated 13 because of 260. 13 into 2 is 260. 13 into 20 is 260. So 261 not possible. That brought me to 29. So I saved a few seconds by looking at the options. That's also something I want you to take away. Right? So what did we do? We translated the information that's given in words into actual visuals. By visualizing that, we kind of figured out, oh, this is a rectangle. So there are these concepts that are relevant. Because this is a right angle, this bisection is happening. Only because you figured out it's a rectangle, you have to do that. Then when you're solving the quadratic, you applied the constraint. Don't forget, there is a constraint which you have to apply. Right? And then use the choice as clues to avoid complex calculation. You could spend all your time, for example, if the option had root 261 divided by 2, you would have been wasting your time if you calculated it all the way to 3 root 29 by 2. So that's why take a peek at the options at this point of time. It's fine. You can save a few seconds. So I hope this is helping you in that sense. Yeah. All right. So now let's come to the 700 level question again. You guys have already solved this question. I'm going to bring the poll for this. You guys are going to solve this again now. And let's see how we do it this time. As always, guys, do click on still solving. That way, it helps everybody. Yeah, I'm going to reopen the poll. You should be able to select it now, guys. So I hope the session is helping you so far in terms of telling you what you need to do as far as geometry is concerned, right? Geometry is not difficult at all, but it is a little more effort intensive compared to, I would say, number properties and things like remainder theorem in number properties. Those questions you will solve in seconds if you know how to solve them. But geometry sometimes takes a little more time and effort. You have to give you that. Will we share the slides? Absolutely yes. At the end of the session, we're going to share the slides. I specifically want you to go through those theory slides also. So I'm sharing those slides at the end. All right, so here's the question, folks. All the best. But again, this is your round 2. I don't think it should take you that much time. Okay. All right, so I see most of you are done. So we're going to take a few more seconds for this, another 15 seconds, and then we'll take a look. All right, folks, so last 5 seconds. 5, 4, 3, 2, and 1. So I'm going to pause. All right, so I'm going to broadcast the results. So this is very interesting. The percentage of people who got it right has remained the same. So this is a question where there is still that confusion for some of you. We're going to discuss that. And I already know where the error is coming from. For those of you who went wrong in this, for those of you who continued to get this one right, I'm very, very happy. So let's discuss this. Here's a very interesting question for you. Which of these 5 options is correct? Now that you've seen the question. Dhaval says A, Surabhi says E, so A, D, A, E, Ritvik says E. Alright, so I'm just waiting for a couple of you more. Tim says E, Vaishnavi says D. Alright, so I know for a fact this is why some of you went wrong, right? There's a very important lesson here. Just because it looks like a rectangle, don't assume it is a rectangle. The question never told you it's a rectangle. It only told you it's a quadrilateral. And the figure very conveniently looks like a rectangle. Don't assume it's a rectangle. For all you know, this is not 90 degree, this is some 91 degree. For all you know, this is a 10 centimeter and this is a 7.5 centimeter. Or 7.25, whatever is given. Exactly, the answer is E, because all these things that you see apply at some level if it's a quadrilateral. Don't go just based on what is given here. The question only told you it's a quadrilateral. It looks like a rectangle, but don't be sure it's a rectangle. The figure is given specifically for statement 2. That's true, but shouldn't be used for statement 1. Not really. I think here it is just given as a figure. But yeah, good question. So here in statement, I mean, if it's actually given for statement 2, that's also a fair point. Should I consider it only for statement 2? The mistake a lot of us have made is we assume that is the figure as given in the question. The answer is E. We have no idea if it is a rectangle. That's the point. So nothing in the question suggests that this particular figure that was given, as Ravi points out, along with statement 2, nothing tells me that that is the figure. Nothing tells me that this figure is drawn to scale. Like I said, this instead of 90 degree, this may be 91 degree. And even that makes it not a rectangle. So that's a very important learning for you. Don't assume that. If that is clear, now look at statement 1. Because now it gets very interesting. So all those properties of diagonals, all those rectangle properties that you are thinking about, unless you can infer that it's a rectangle from statement 1 or statement 2, you cannot assume it is a rectangle. So that's the first core point here. Now let's talk about this EC equal to 5 centimeter. If this is clear, which of these is the correct statement? Which of these can you not, or none of the above means that none of the above can be said with confidence. I know that EC equal to 5 centimeter. That is this. Luis, quadrilaterals, think about trapezium. Are the opposite sides necessarily equal? In a trapezium, those opposite sides are not equal, right? So some of you who said 4, you're rushing through. Pay attention. Irrespective of what the nature of this quadrilateral is, AE plus EC is still going to be equal to AC, right? That doesn't change. So obviously you should not be choosing 4. 2 is still correct. This was just a trap to see if you guys are paying attention at the fag end of the session. So some of you fell for it, but yeah. Think about it. This point is anyway true, right? But fundamentally, if you analyze statement 1, the problem is based on this, you cannot do any kind of analysis that tells you about AB and BC. You have no idea. With statement 1 practically is useless. Statement 1 is practically useless in analyzing whether AB is greater than BC. On the other hand, let's talk about statement 2. When you read this, your radar should go up. All interior angles of ABCD are right angles. Or in other words, 90, 90, 90, 90. Based on this, what can you say about quadrilateral ABCD? Exactly. Now you know it is a rectangle. The minute you know it's a rectangle, things change. Right? So because it's a rectangle, what do we know? Opposite sides are equal, right? All sides are not necessarily equal. It's not a square, but opposite sides are equal. Exactly. Now, given the knowledge that it's rectangle, this is where you should retrieve the information from your brain. What is relevant to rectangles in the context here? I know that it's all about AB greater than BC. Look at the next sentence, this particular sentence. Statement 2 says, firstly, you're talking about a rectangle. Great. The perimeter of AEB is greater than the perimeter of BEC. AEB and BEC are rectangles, right? Triangles, right? AEB is this triangle, BEC is this triangle. What we're being told is this perimeter is greater than this perimeter. Fantastic. Now, because it's a rectangle, what can you say about diagonals? Equal length. Also, they bisect each other. Don't forget that one as well. They are equal length and they bisect each other. What does that mean? In simple words, this is equal to this, is equal to this, is equal to this. AE equal to EB equal to EC. Why is that important? With that information, now talk about calculating the perimeter. We are given the perimeter of triangle AEB is greater than the perimeter of triangle BEC, right? So what is the perimeter of triangle AEB? AE plus EB plus AB, right? Likewise, perimeter of triangle BEC, BE plus EC plus BC. Simple. Because it's a rectangle, diagonals are equal, diagonals bisect each other. Does it not mean that these 4 terms practically cancel out each other? And does it essentially not lead to AB greater than BC? In other words, statement 2 as it stands is sufficient. Which is why the correct answer, which 45% of you got it right this time, is option B. Now, those of you who did not get option B, tell me what went wrong. Why did you not get option B? Where did you falter? That's where your learning will come from. What is it that you missed on? I don't even need to know the dimensions. That's the beauty. I don't need that option. I don't need that statement A telling me that this is 5 centimeter. I don't need that information. This can be X for all I care. Fundamentally, this would be X plus AB, whatever AB is. I don't need the 7.25 also, frankly. Greater than X plus BC. All these X's cancel. Irrespective of whether AB is 7.25 or 10, I don't care. AB is greater than BC. Actually, I don't mind. You got the, if you are confident you got the answer, nothing like it. Don't worry about it. This is a completely roast. This is not your official GMAT test, so I wouldn't worry. You thought I could use statement 1 to find, yes. That's the point about data sufficiency, right? You need to know, you need to get that sense of what you really need to do versus what you don't need to do. Yes, so Dhaval, that's a very important learning for you. The minute you figure out it's a rectangle, think about how I can use that information in this context to figure out this. So it's a very good question, right? That way, really tells you what you can do with regard to quadrilaterals, how deep you can think, what is it you really need to do, what versus what is it you don't need to do. In this case, the 7.25, nobody cared about. The question didn't test you on that, no, anything with that. So there are questions like this. You should be ready for that. So everybody is clear? Any questions? Anybody has a doubt about any of this? Let's put a yes, no. Everybody is clear so far? Then we can move on to the next question. We are going to discuss the last data sufficiency question as well. Good. I like to see this clarity. Perfect. Now, so I hope you're taking those lessons from this. It was a rectangle, then diagonals bisect. No, in all those except trapezium, I don't know. But even if it was a parallelogram, the diagonals would have bisected. The key information, because it's a rectangle, is they not just that they bisect, but they're also equal. So because they bisect, this would be equal to this. But because it's a rectangle, the diagonals are also equal to each other, which means this is also equal to this. So slight things. You couldn't have solved this problem this way if it was a rhombus or a parallelogram instead of a rectangle. So subtle aspects. You will get a recording. Do not worry about that. You'll receive it on your email. So I hope the learnings are clear. Use your conceptual clarity. It's only when you figure out, okay, rectangle, let's figure out. Only when you think on those lines can you make all these things. You can arrive at all these calculations. Another key learning here, do not just assume based on the figure given to you. Yeah, unless the question tells you that the figure is to scale, this is exactly what it is. Don't assume. All right. So at this point, very quickly, I'm going to run you through what we have going as far as e-GMAT is concerned. What does it scale? Throughout the session, what you've seen so far is a very layered approach to quant. It's not just that you learned some concepts. Beyond concepts, there was something called process skills, and we kind of explained to you what those process skills were. So now you kind of understand that as far as learning quant for GMAT is concerned, it's not just about learning concepts. Again, I warn you, if you think that you can just brush off on your concepts and come to the exam, for some of you that will work, but not for all of you. So you might be risking if you're doing that. Okay. Concepts are important. You learn the concepts, but beyond concepts, there are all these process skills at work. Figuring out what to use when, translating the information into a usable form, drawing those inferences, applying those constraints, knowing when you should not be taking that negative versus when you should be taking that negative value. Those process skills are important. But this alone, at a simple level, process levels, at a fundamental level, is not going to get you, because GMAT tests you on a refined level of application of these. So in terms of content, you should have concept level content, process skill level basic content where you're learning to apply these things, and GMAT level questions as well. 3 layers to the content that you should be having typically, and we have it right now. That's why Quant 2.0 has been so successful. So you can see that bifurcation here. What I'm highlighting here are purely the concept files, which is dedicated to learning the concept. Then you have files dedicated to improving your ability to apply those processes. Now, then you have the actual GMAT style questions. This is where you really get the flavor of applying all this in a GMAT type environment. So understand that there is a reason the content is built in a progressive way, because we've kind of figured out that it actually leads to success. So when I say success, I kind of mean it. If you talk about Q49 plus 49, 50, 51 scores in recent times, e-GMAT has typically been known for its verbal course, but last year we set out to change that. So early last year we came out with Quant 2.0, and this is kind of the results since then. And this is slightly outdated data, but even the current data points tells me the exact same picture, that in terms of success, what we have been doing is working out for us. Now, why am I stressing so much on this? Because as we figured out, even in this class of 50-60 students, there is a big difference between us, right? Some of us are here, some of us are here, some of us are here. So there is that big difference between us. So does everybody go through all these aspects the same way when we are going through the course? Absolutely not. Each one of us needs a unique solution. I'm going to take just one example, the example of geometry, to clarify this concept. Geometry in total has 76 learning activities. That's a number of files that you have. 40 hours of content. But who needs to do what varies based on who you are right now. Somebody who's already very, very strong, Q49, Q50 types, needs to go through just 12 of those activities. The time investment is also very, very different from somebody who's at a Q30. This guy has to go through all the concepts. So there is a difference in the time investment based on the student, and the program is systematically designed to give you that relevant feedback. If you belong here, the system will tell you, hey, you need to do only this. If you belong here, the system will tell you, okay, you need to focus on these activities. That's the level of personalization that we have built in, right? The third aspect is very, very important. I already talked about how this diagnostic works, but fundamentally, a very, very important aspect of the course. How do you know that you have excelled? Okay, you know that you have to have this progressive architecture. That's really, really great. You're also know about personalization. That's great. So based on your current ability, you're going to learn. Fantastic. But how do you know that you're picking up what you should be picking up in terms of your abilities? That's where the feedback piece becomes very important. So this is where expert AI comes in. It's grading you on everything that you do, even in a concept file. Forget exercises in application files or practice quizzes and all that. Even your concept file, you're being assessed. Some parameters which we look at include, have you really gone through the concept? Have you actually completed the concept? And did you just rush through it, or did you spend enough time on it? The system is actually tracking all this. And of course, it's looking at your scores as well. It looks at all this and it's able to tell you that, hey, this is something you seem to have learned perfectly. All right, this particular concept, you still need to put in a little bit of work. This particular concept, hey, you just run through. You really have to go and redo it. So there's that level of feedback that is set into the system at this point. So couple of examples, anecdotal evidence for you. Varun was able to save a hell lot of a time in his GMAT preparation thanks to Quant 2.0. The amount of things he actually had to revise, very, very minimal compared to what he would have otherwise done if he had gone for, a typical book-based course. Similarly, with Anant, you see the same thing. The diagnostics, those initial couple of diagnostic quizzes I told you about, they told him that, hey, you need to focus on these two, algebra, geometry. You don't need to focus that much on arithmetic. And that gave the time improvement, that helped him focus his time and energy only where it really mattered. There's another example for you. And all these are available on YouTube, right? I will also send YouTube links to all of you. You guys can check it out. But now let's get back to the quizzes. Let's get back to our question. Here is the next question for you. After this will be the second last question, I guess, before we get into the last DS question. And I'm going to bring the poll for you. Again, not really a difficult question, but let's start with still solving and get right to it. More still solving, folks, so that way in this entire session I have not been timing you. If it was a workshop, I would have timed you and I would have rung the bell at 2 minutes sharp. But this session, it's meant to be a skill building session, and that's the reason I'm not putting any time constraints on you. Okay, so now let's solve the question. Alright, so most of you are done. Let's take another 15 seconds. That's for the rest of you. Alright, folks, last 5 seconds and then let's discuss this. Take your best shot. 3, 2, 1, and take your best shot, those who are still remaining. Okay, I'm gonna pause now. Let me broadcast the results as always. Good show. 63% of us did get the right answer, which is option E, by the way. Of course, it's right. So, again, the approach is more important. I don't want any of you to get bogged down by questions like this. Start from scratch. Ravi, to just address the question, I think Anshuman has already addressed it, but what we have here is more than sufficient for the GMAT. I always like doing OG questions also, but if you're doing OG, typically even in verbal, we always say the OG advanced is slightly better in terms of the questions that you'll solve. So that's just there. e-GMAT scores is good. It's given us, even we have had success stories of people who didn't do many OG questions as well. So it's doable as far as I know. But if you are going for OG, do look at OG advanced. I think you'll find better questions there overall. All right. So this question, when it says a border of uniform width placed around a square photograph, immediately your brain should visualize the square photograph. Border of uniform width. What do you mean by uniform width? Which means if it is some particular distance this side, it's the same distance here, it's the same distance here, it's the same distance right here, right? This is what we mean by uniform width. Am I correct? This gap has to be the same, all sides. Otherwise, it would not be uniform width. If it was this much on this side and it was this much on another side, this would not be uniform width, right? That's the first thing you should understand. What is meant by uniform width? If this is clear, let's kind of move on. So you have the square frame, square photograph, and then you build a border around it which has uniform width. We are given that the photograph side is n. We are also given that the width of that border is p. What do we need to find? Area of the border, right? So what is the area of the border? This is something that a lot of us have solved in school as well, but let's kind of document it here. What is the area of that border? How do you find the area of the border? New side is of course n plus 2p. It's all about this, right? End of the day, it's the area of, it's the big area minus the small area, right? Area of the photograph, area of the entire section, so that is photograph plus the border, minus area of the square photograph. Big square minus small square, right? Exactly. As simple as that. Everybody clear so far? Anybody who was not able to figure this one out? But this is fundamentally that skill of visualization. Once you form that picture of square with uniform border, immediately when you see area of the border, you know it is area of the big square minus area of the small square. It's as simple as that. So this we already discussed. The minute you are adding uniform width, if this is a square, the bigger thing is also a square, right? I think there's a very similar question. Yes, but this is not that question, but it's a very similar question. That's why the lingo might seem very similar. Eventually, if you have the ideas can be communicated in a limited number of ways, so I'm pretty sure that's why you see that similarity here. But everybody's clear so far? So the inner square photograph is a square, but it's also, isn't it obvious that the outer thing is also a square? Because of that uniform width. Just checking. Everybody with me? Anybody who struggled so far? I am assuming that you guys got this because I don't see anyone saying, "Oh, I didn't understand this." So that's there. This is something we have. I mean, yeah, most of us have solved in school at geometry 15 or 20 years ago, right? So obviously this is B. It's a square. Now let's move on. So very easy. A lot of times the silly mistake that students commit here is instead of saying n plus 2p, they forget that you have to count both sides. Sometimes we just say n plus p. Yes. Do you understand the concept of uniform width now, given this explanation? Other, if otherwise it would not be the case, right? If you had, this is the main square, if the width was this much on this side and this much on this side, it would not be uniform width, right? That width is not uniform anymore. Absolutely. So the mistake a lot of students sometimes make, just a silly mistake, is instead of considering this new length of the bigger square to be n plus 2p, they forget to count both sides. They just take n plus p. I hope none of you did that. If any of you did that, let me know, because you know where you are. You know that's a silly mistake that you should be avoiding. So the photo with the border, the actual length is n plus 2p. So we are talking about areas. So it's a square rather. So it's both sides is n plus 2p. So old area is n square. New area is simply n plus 2p the whole square. How do you find the area of the border? Big square minus small square. Simple. The minute you do big square minus small square, you should be getting this option, that is option E. Here Nish, yeah, we will send you the material anyway. Okay. So there were some of us who did not get this answer. A, B, C, and D were also chosen. For those of you who did not choose this, is this clear? Any doubts? Uniform width, I think, yeah, that can throw you off. So now you know about that. The other mistake I typically see here is this n plus p instead of n plus 2p. Those are the mistakes that students sometimes make. Most people I find are already familiar with, subtracting big square minus small square to arrive at area of the border. All right. If this is clear, we can move to the last question of the day, which is, by the way, one of the first questions of the day that we already worked on. But we are going to do this now with all the understanding that you guys have built. So let's move this away. All right. So very quick still solving. Those were here. This way we can see if we have any, again, we are seeing any improvement from our last performance. All right. So here is the question yet again. All the best. So this is probably the most difficult question of the day. I'm gonna give you a little more time. I still see some of you are struggling. I see some of you changing your answers as well. All right, let's take another 15 seconds or odd, something like that. I'm happy to give you time. All right, folks, last 10 seconds. Three, two, one, and those of you who are still stuck in still solving, another 2 to 3 seconds for you. And one. So this is the last question of the day. So how are we feeling about this question? This was a difficult question. I still see it's a difficult question for some of you. Some of you got it right immediately as well. I saw that as well. Very quick round of comments. How was this question before we jump into discussing this? Should not take much time given the level that we have reached through this session. Results are a mixed bag. I'm going to broadcast the results so that you can kind of go through it. There's only one correct answer though. Torn between two answer choices. Which answer choices were there? Were you torn between? C and D. Okay, C and D. Both of you. Okay. This is going to be interesting. So let's discuss this. And do pay attention. This is the last question you're here. You should get the full insight from this question. So firstly, similar to the last question, a border of uniform width W is placed around a rectangle R. Right? So this time it's not a square, it's a rectangle. So you have a rectangle R and you have this border of uniform width around it, right? To create a bigger rectangle S. So there is R and there is S. That's a bigger rectangle. Now we are given if the difference between the perimeters of S and R is 16, what is the perimeter of S? Again, the mistake, Ragini, okay, the answer by the way is option D, but we are going to see why. And that's why you should understand why if you have not chosen it, especially. If you've chosen it, fantastic. So, pay attention. There's the difference between the perimeters of the small rectangle and the big rectangle is 16 units. What is the perimeter of the big rectangle? That's what we're being asked, right? So again, let's very quickly discuss. If the length of the rectangle is R, is A. If the length of the smaller rectangle is A, what is the length of the bigger rectangle? We've already discussed this. This should be very, very straightforward at this point. The concept remains the same. Absolutely. Don't forget the second width. Both these widths should be considered. So far, so good. Now let's move on. Again, do not make the mistake of directly jumping to the statement without analyzing what is given to you here. So, what are you given? The difference in perimeter is 16 units. So, this is the first rectangle, smaller rectangle. This is the bigger rectangle. These are the sides a plus 2w, b plus 2w. What is the perimeter? 2 times length plus breadth. Here it is 2 into a plus b. Here it is 2 into a plus 2w plus b plus 2w. So far so good. Now we know that the difference between these two perimeters is 16 units. So if you put that in other words, perimeter of bigger rectangle minus perimeter of the smaller rectangle is 16 units. Did you guys simplify this? You can actually find out the width. How many of you found out that this w equal to 2 before you went to statement 1 or statement 2? Perfect. Now you are doing data sufficiency the correct way. Because if you have done this, then you are setting yourself up for success. If you did not do this, you're practically setting yourself up to fail as far as this question is concerned. Now, it's still not done. The mistake a lot of people make is, after doing this, did you directly jump to statements? Okay, you found out that w equal to 2. How many of you went directly to statement 1? Or the other way? How many of you did not go? Whichever way. Did you go directly to statement 1 or did you do something else right here with the information that's given to you? So this is where that refinement will come from. Sometimes people are in so much of a hurry to rush through and go to the next statement. Okay, you felt very happy with yourself for figuring out that w equal to 2, and then you just went directly to the statements. Yes. What Ravi has said is exactly what you should be doing. If you found out that w equal to 2, you should be figuring out everything here before you jump to the answer statements, before you jump to statement 1 and statement 2. Or in other words, what can you say about the length? A plus 4. What can you say about the width? B plus 4, because w equal to 2. What can you say about the perimeter? 2 into a plus b plus 8. What is it you need to find here? Perimeter of the bigger rectangle. Or in other words, you need to find this. Everybody with me so far? So essentially your problem has been translated to this. You found out your width, it doesn't matter anymore. All you have to find out is, just like in those first questions, you need to figure out a plus b. If you can figure out a plus b, you can get the perimeter of the bigger rectangle. It boils down to finding out a plus b yet again. Did you reach this before you went to statement 1? That's the first question. Because if I look at the answer choices, most of you did not actually choose the correct answer, which is option D. So many of you did not figure this out. So I have to ask. Abhi says, I ignored W, took 2 side lengths. But if you had figured out W, you could have figured out this everything about the problem right here. So what seemed like a more complex question, it actually boils down to this. If you find a plus b, you can find the perimeter of the bigger rectangle. And each of the sides is just a plus 4 and b plus 4. I was good until this, but I don't know where I made the mistake. So good. You just have to go back and see where you lost the ball. So if this is clear, now let's go to statement 1, right? Because now you know exactly what you need to find. That's this 2 into a plus b plus 8. If you find a plus b, your problem is solved. Now, we have already discussed this, right? Which information is needed to find the area of the border? I think this point we have already discussed. Let's just move on. Let's go to statement 1. The area of the border is 52 square units. We already know how to find out the area of the border, right? What is the area of the border? Area of big rectangle minus area of small rectangle, correct? Now, a lot of you might have complicated this by putting a plus w, b plus w minus ab, and then figured out. If you have not yet figured out what is w, then you would have been stuck with a lot of unnecessary algebra here. Uniform width across all the dimensions, across each side. Uniform border means uniform width all across. Good question. So instead of putting w, you already know this is 4. All I had to do was a plus 4, b plus 4 minus ab. If you simplify this, your ab's and ab's will cancel out. This essentially becomes, this translates to ab plus 4a plus 4b plus 4 into 4, 16 minus ab. Your ab's cancel out. You are left with 4 into a plus b plus 16. Now, I honestly don't care what A or B individually are, but I'm perfectly able to find out what is A plus B, right? Ravi has already calculated it, right? You can find out A plus B, which means if I find out A plus B, then remember that the perimeter I'm looking for is nothing but 2 into A plus B plus 8. I found out A plus B, which means I can find out this required perimeter. In other words, statement 1 is sufficient. For those of you who did not figure out that statement 1 is sufficient, is this clear? Why is statement 1 sufficient? Is this clear? Quick show of hands. Let me put it to a poll. The concept is very simple, right? Is it clear why statement 1 is sufficient? So whoever has no, put it out. We will answer that as well. Don't worry about it. All right. So now let's move to statement 2. Statement 2. S can be obtained if each of the longer sides of R is increased by 80%. Each of the shorter sides of R is increased by 100%. Now we have already kind of discussed, when you say increase by 80%, A becomes 1.8 of A. Width increase, the shorter side of R, that is the width of R, increased by 100%, or in other words, this should become 2 of B. So as all of you are pointing out, these are the length and the widths of the larger triangle. So far so good. Now again, if you have already figured out that, hey, the length of the new rectangle is simply A plus 4, and the width of the new rectangle is simply B plus 4. Essentially, A plus 4 equal to 1.8A, and B plus 4 is nothing but 2B. Can you see what's happening here? Unless you've calculated width to be equal to 2, and you figured out that therefore the new lengths and the length and breadth of the bigger rectangle is A plus 4 or B plus 4, this may not even strike you. How many of you were able to figure this out? Essentially, all this means is, hey, based on this I can calculate A, based on this I can calculate B, which means I know A, I know B, which means I also know A plus B. Because I know A, I know B. And if I know A plus B, again, that perimeter can be easily calculated. It's nothing but 2 into A plus B plus 8. Or in other words, statement 2 is also perfectly sufficient to give you the correct answer, which makes the correct answer not option A. The correct answer is option D, because both statements are perfectly sufficient on their own. So Anshudhara, you evaluated statement 1 correctly. You did not analyze statement 2 properly. In all probability, you did not figure out this point. Am I correct? So, very few of you got the correct answer here. What did you learn? Essentially, both are perfectly sufficient, because all I cared about was A plus B. In both cases, I can get A plus B. So this is a good question. These are actually 2 questions in one. Ragini, you are 100% right. Can you go back to the last slide? Yes, I can. Yes. Abhi, you're perfectly right. You have to do a very thorough question analysis. If you had done that, this question, you would not have got into overly complicated algebra while still keeping W as a variable, for example. Otherwise, you're keeping W as a variable, or the new length is A plus 4 will not strike you. So all those inferences you will not be able to draw because you did not do the question analysis to the required level upfront. It's a very important aspect. Right? How can we calculate unique values of A and B with equations from second statement? What does the second statement say, Ravi? S can also be obtained, or in other words, the bigger rectangle can also be obtained if the longer side is increased by 80%, or in other words, A becomes 1.8A and the shorter side increases by 100%, or in other words, B becomes 2B. But we have already calculated that the longer side is A plus 4 and B plus 4. It's the same rectangle, right? So think about it. If 1.8 a equal to a plus 4, can you not calculate a based on this? Essentially, this will give you 0.8 a equal to 4. Therefore, a equal to 4 by 0.8. Likewise, the other equation is 2b equal to b plus 4. You can calculate b. You know a, you know b. Calculate a plus b. Addition. Exactly, now you got it. So, very important lesson there. Do not skip that question analysis. So, any feedback on this particular question? Anything you'd like to say on where you lost it, if you lost it, or if you got it, fine, your learnings, whatever it is. Make sure those are your reflections on what you can do better. So, next steps, very simple. If you're already an e-GMAT student, some of you are. In that case, the Quant course, the 2.0 course is beautifully designed. It's tremendously successful and it works because there's a reason it works. The architecture is brilliant. Go through the Quant course, follow that expert AI, go through those recommendations, get through. Even if you are not an e-GMAT student, you still have a lot to benefit. If you liked what you saw here, if you like the methodology that we're following, the very systematic breakdown of concept skills and process skills and all that, do consider going through a free trial. You can register at e-GMAT.com. There are aspects that are available for free. So as a free trial student, you kind of want to evaluate if this is a learning style that matches what you want from Quant. If it is something that makes sense for you, do consider registering as a paid student as well. So just for context, as a free trial student, these are the files that you would get for free if you register on e-GMAT.com. With that, I'm done with the end of the session. Any quick feedback would be welcome, but at this point, I'm going to share all the relevant material with you. And meanwhile, just drop in your feedback, guys. Anything you felt was okay, any learnings that you had, anything else you want to document, everything is fine. I hope the session was useful for you. It usually is, but yeah. Let me bring in some links for you. So first things first, session PDF for those of you. I specifically want you guys to spend time going through that theory slide for quadrilaterals, internalizing those, see in what cases what is happening together and what is not happening together, because that's how you'll be able to internalize these things very, very clearly. I don't want you to by heart them. I want you to internalize them. There's a difference there. Okay. So tomorrow, if you're solving a question on, rhombus, you should know exactly what is it about a rhombus that what are those properties. Let me bring in some other links as well for those of you who are looking for it. We discussed a couple of anecdotes of students like Varun, Anant, Dipinti. You can actually listen to what they say, hear it from the horse's mouth, how it has helped them. Maybe even for you, this might be very, very useful. So take a look. The process skills video set that I was talking about, those are here for any of you who need that. And last and final, let's also talk about the PSP link. For those of you who want to get in touch with us because you want us to help with your building a study plan, etc., that link is for you. The last link is for you. So let's see some feedback. Thanks a ton. Thank you, Anshudara. Dhaval says solve the questions before jumping. Very important learning. Ravi was solving by equating areas. Yeah, different approaches do work. This question will haunt me for the day. That's good. Abhi, the point is, I don't think you'll ever make the same kind of mistake again. In another similar question, you are never going to make the same mistake again. So that's, any feedback is good feedback. You learn from it. Share details of about upcoming sessions. So yes, let me bring in that as well. Upcoming free sessions are next Saturday is strategy, and next should be here. Next Saturday is strategy, and next Sunday is number properties. So unlike geometry, number properties, some of these questions you'll solve it in seconds. For those of you who are already strong with number properties, you know exactly what I'm talking about, right? So thank you, very helpful, informative. All right. So I hope that helps, Ravi. Those are the upcoming sessions. How to register? Those links ideally should be clickable. Okay, they're not clickable. So just reach out to us, Ravi. We'll make sure you get it. Let me just put this link here. just reach out to us and say, hey, I need the links to register for the upcoming sessions. We'll help you out. Ideally, these links should have been clickable. I don't know why they're not, but yeah. Probability sessions. We do probability occasionally, not in this set, but we do a couple of sessions on GC and probability. I don't know if it's coming soon, but yeah, we do have sessions on that. So just watch out. You should get something. Thanks for the feedback, Abhi, Yasho, Vaishnavi, Ragini. Patient teacher, yeah. I know. The session has gone on longer than usual, that's true. Yeah, there should be an option to book from there. Don't worry about that. All right.